Okay, we have here today a really unusual looking integral from the MIT Integration Bee 1991, problem 18. We have the integral of 1 over pi x squared plus arctan x plus x squared arctan x plus pi dx. Okay, now obviously we've got a crazy denominator going on right here. And there's something about it when you have a crazy denominator like this that makes me think that it's actually not going to be too hard, that we just need to factor this. Especially with the arctan, as we usually can't really deal with it. We only have a few ways to deal with arctan, so I'm thinking factoring is going to be the way to go. So I think first what I'll do is I'm going to just group our arctans and factor that. So we obviously have the arctan in common, so if I factor arctan out of that, then this is going to leave me an x squared here, and this one's going to be just a 1. So we'll have this arctan x times x squared plus 1. And then let's group we'll group the pi and the pi x squared. So if I factor a pi out of that, we get x squared plus 1. But now let's just rewrite this. What we have is we have arctan x squared plus 1, and we factored it to pi x squared plus 1. But now we have this x squared plus 1 in common in both terms, so now we'll factor an x squared plus 1 out of this, and this is going to turn into just x squared plus 1 times arctan of x plus pi. So now let me just rewrite the integral, and we'll just take this and we'll put this in for our denominator. Okay, so now with the rewrite, the thing we need to deal with again, it's just this arctan. We can't really have that there. Now generally with arctan, there's only like two ways. You want like integration by parts or a u sub. In this case, let's do a u substitution. And so what I'll do for my u sub is, let's make this whole thing u, because pi is just a constant, so that's just, we kind of get that for free. So we'll make my u substitution, it's just gonna be arctan of x plus pi. We'll take a derivative. Du is going to give me, this is going to be 1 over x squared plus 1. Again, that's 0, and we just get a dx. But then what happens there is if you put a 1 there, this whole thing here, this is actually our du. So doing the substitution, we're going to end up with just du over u. Integrate, this is going to give me natural log absolute value of u. Just back substitute in order to finish it off. And for my final solution, we're going to have just natural log absolute value arctan of x plus pi, put a plus c, and that's it. There you have it, MIT 1991. Thanks everyone for watching. Have a good day.